Right, grade 9. So, this is a quick revision of your grade 8 work. So, this is from grade 8. Right? See that revision, or it gives you a chance to catch up. Right, we're going to be doing atoms, elements, and compounds just to quickly remind ourselves of what they really are, because it links to the topic that we are about to do in term 2. So, matter is divided in three types of forms. I say three types, and I wrote four over here because of the atoms and elements almost one and the same. But you'll get to see. So basically, we have atoms and we have elements, and then compounds and mixtures. Many people confuse the two between compounds and mixtures. They're not the same. So we'll get to look at each and every one of these individually, and then understand them, right? Good. So what are elements? Elements are substances. So those substances that are made up of only one type of atom and cannot be broken down into simpler substances. Whether in a chemical reaction or physically, you cannot break them down into simpler substances. If I give you carbon dioxide, for example, which we're about to do right now, not carbon dioxide, sorry, excuse me on that one. If I give you hydrogen as a gas, right? Hydrogen as a gas is basically is an element. If I break it down, I can only end up with two hydrogen and nothing else, right? Good. So it's basically made up of one type of atom. This hydrogen gas, although there's two of them, but they're essentially made up of hydrogen and hydrogen. So oxygen alone is made up of oxygen. If I break it down, I can't break it down into anything simpler. It's one oxygen atom. So that is basically what an element is, right? So what is this atom that we speak of? So an atom is basically the building block of all matter. All matter in the world. The pen that you're using right now to copy down my notes, you as a person, your very DNA is made up of atoms. It's the building blocks of all matter. Basically, all matter is made up of atoms. Just to add, just a reminder, what is matter? Matter is anything. So matter is anything that has mass. So matter must have mass and occupy space. So all that is matter arises from atoms. And atoms make up what? Atoms will make up elements. And elements are only one type of atom. Good. Now, all elements, they classify them according to their different properties, but we'll get to that later when we do the periodic table. They're basically grouped into this nice little table by Dmitry Mendeleev into what we call the periodic table of elements according to their properties. Great. Now, all of these elements, most elements exist as a single element, like your iron, for example. Iron exists as a single element, copper, I think gold as well, Ag. It exists as a single element. So those are elements. They're made up of one type of atom. This is iron, made up of an iron atom. Copper made up of a copper atom. Silver made up of a silver atom. Good. But some elements will exist as diatomic elements. And those are the elements, basically, most of them are gases. Gases exist as diatomic. Remember the prefix. Prefix di means two. So they exist in in pairs, basically. But they are still the same type of atom. So that is still an element. A list of them is here. Hydrogen. Hydrogen exists as two hydrogens bonded, one hydrogen bonded together to another hydrogen. That is still an element. And then nitrogen as well, oxygen, fluorine, chlorine, bromine, and iodine. Notice that most of these gases that exist as diatomic elements practically belong to a group of elements called your halogens. Your halogens, they're in group 7 of your periodic table. So these are your diatomic elements. They exist in twos. So they are still what? They are still elements. So we can have the same element but different structures. Those are called allotropes. You get to learn them as you go to higher up into physics. So for example, oxygen. Let's take oxygen for example. Oxygen alone is monoatomic, meaning it consists of one atom. It's a single oxygen atom, but it's still an element because it's still made up of one oxygen atom. Then oxygen is a gas in the atmosphere. It exists as O2. That is a meaning two, diatomic element. And then your ozone molecule exists basically in three. So there's three oxygens bonded together. Is this still an element? Yes. Why does it be qualified as an element? Because it's made up of one type of atom, which is the oxygen atom. So that is an element. So what are compounds? So compounds are basically substances that are made up of two or more. Now here's the valuable word I want you to pay attention to: different kinds of elements. Now, a compound is a substance made up of two or more different types of elements that are chemically bonded together in a specific ratio. I'll get to explain what is a ratio done after I'm done with this. Now, two elements bonded together. Let's say hydrogen plus a hydrogen to give us hydrogen gas. This is not a compound. Why? It's made up of one type of atom, which is the hydrogen atom. So for it to qualify as a compound, it must be made of different atoms. Carbon plus oxygen to give us carbon dioxide. Carbon dioxide qualifies as a compound. Why? Because we have how many different types of atoms? Two different types of atoms. And what are they? Carbon and oxygen. So that is a compound. I hope you get me. So each compound is represented by a formula that uses symbols basically to identify which elements are present. So you can see in a formula that that represents a compound. That I see in CO2 there's carbon and then there's oxygen in that. So a formula will show you the ratio. Hence we say a compound is a substance made up of two different types of elements chemically bonded in a specific ratio. So the formula will show you the ratio of elements, and that will tell you what type of compound is formed. For example, H2O. H2O is made up of two hydrogens and one oxygen. So the ratio of hydrogens to oxygen is 2:1. Similarly, I can have carbon monoxide and carbon dioxide. The ratios to these are different. The ratio for carbon monoxide is 1 carbon and 1 oxygen. The ratio to carbon dioxide, however, is 1 carbon and 2 oxygen. Let's take salt, for example, NaCl. What is the ratio for sodium chloride? How many is this a compound? Let's first start. Yes, it's a compound. Why? It's made up of 1 sodium and another different type of atom, that is the chlorine atom. So I have 1 chlorine atom and 1 sodium atom. So the ratio is 1:1. So basically that is what we call a ratio. Yeah? Good. So compounds cannot be broken down by physical methods. I can't just say I see water. Okay, let me physically take the hydrogen away from the oxygen. Good. I can't do that. I can't do that. If anybody can do that, please let us know if they can separate compounds physically. You'll be rich one day if you can do that. So compounds have definite compositions, which the element ratios indicated by the subscripts. So how do we tell that the ratios? With the subscripts. So subscripts are these little numbers basically at the bottom of each symbol of an element. Good. So like with H2O, you can see there's 1, 2 hydrogens. So we have 2 hydrogens plus 1 oxygen. So the ratio is 2 is to 1. Good. So compounds. The properties of compounds basically vary according to the compound itself. Good. For example, sodium chloride, NaCl, is the formula for salt. That is a compound. It's made up of sodium. I usually like to write it myself because it's small letter A. Sodium plus chlorine, which makes sodium chloride. So that is a compound, qualifies as a compound. Carbon dioxide is made up of carbon. It's made up of carbon plus an oxygen molecule. How many oxygen atoms? How many oxygen atoms are there? There is 2 oxygen atoms. So the ratio of carbon to oxygen is 1 is to 2. Then glucose. Your glucose basically it will constitute making up the tables sugar that you eat. Is not just glucose alone, but glucose also is a compound. It's made up of how many different atoms? 3 different atoms. Yeah, good. That is what? That is carbon, hydrogen, and oxygen. So what is the ratio for of carbon, hydrogen, and oxygen in glucose? C6H12O6. That is, and remember how I usually teach my learners to remember this. This might help you in the near future. How to write glucose is basically CH612O6. So let's get back to the ratio. It is 6 carbons, 12 hydrogens, and then 6 oxygens. So if we divide all of these numbers by 6, we'll get the ratio basically becomes 1 is to 2 is to 1. So that is the final ratio. Basically, we divided by the lowest common denominator. So that is the ratio for glucose. I think we understand the ratios now. Now, all compounds, we write them in formula formats. The symbols that make up the formula, we look at the symbols that make up the formula. A formula is just a chemical shorthand for the compound. We can write them in words and we can write them in chemical formulas. So we have the subscripts that let us know how many atoms are present, like I've already explained. So you look at the subscripts that will tell you how many atoms are present. For example, let's say I have this one. Let's go back to glucose, C6H12O6. It tells me the subscripts are these numbers at the bottom. I call them the little handbags. And never, ever, when you write this, change the subscripts. They cannot be changed whatsoever. They are definitely like that. Otherwise, you change the compound. Good. Now, it shows us that we have 6 carbons, 12 hydrogens, and 6 oxygens. Right? Good. So let's do an exercise. How many atoms of each element are present in one molecule of one molecule? Yeah? Good. Let's see. We have how many atoms? Let's first start by identifying. We have nitrogen, we have hydrogen, we have sulfur, we have oxygen. So you must now tell me how many of each of these are there. How many nitrogens do you see? I see 2 nitrogens. Why? Because of these brackets over here enclosing the NH4. So that means this 2 applies, the subscript applies to all of the elements that are inside the brackets, including this nitrogen. So I see 2 nitrogens. Then how many hydrogens do I see? I see 4 inside the brackets. But then again, we can multiply this 4 by the 2 outside the brackets. Then that gives us 8 hydrogens in total. Then sulfur. How many sulfurs do we see? We see how many sulfurs? I only count 1. There's 1 sulfur. because this subscript 3 over here only applies to the oxygen. If it was like this, then this, if there was brackets, then this 3 would apply to the sulfur. So how many oxygens do we have? We have 3 oxygens. So basically that is that. Right, now let's do another exercise to see if we understand what we just did. So let's start with water. It says we have a table over here showing the number, the name of the substance, what is it made up of, and the chemical formula. Water is made up of hydrogens. How many hydrogens? 2 hydrogens. And then 1 oxygen atom. What is the chemical formula? H2O. So how do we represent the subscripts or the 2's, the number of atoms? We represent them under the subscripts. Basically, we write them in the form of subscripts. So, for example, carbon dioxide, it has how many? It has 1 carbon. Good. So I write. So if it's 1, I can't write it here at the bottom as a subscript, where I just leave it because I know it's 1. Then it has how many oxygens? Dioxide. It has 2 oxygens. So I write it 2 oxygen. And the ratio for that is 1:2. Then ammonia. Ammonia, we say it has 1 nitrogen atom. So if it has 1 nitrogen atom on the subscripts, I write nothing. And then 3 hydrogens, I write it as a subscript. So the ratio for ammonia is 1:3. Methane gas, it has 1 carbon atom, so I write the carbon atom. Then it is made up again of hydrogen. How many hydrogens? 4 hydrogen. And then I take that 4 and drop it down as a subscript. So that is basically how we identify these. So these are your compounds in a formula. Good. Now, what holds these atoms together in a compound? These are in what we call forces. Forces, or you can say intermolecular forces. Molecular forces. For now, that's all you need to know. Good. Then molecules. What are molecules? We've done compounds, we've done elements, we know what is an atom. So what is a molecule? A molecule is formed when 2 or more atoms are joined together. Yeah? Think about it. A molecule is formed when 2 or more atoms are joined together. So does that mean a compound is a molecule? Yes. A compound is a molecule, but not all molecules are compounds. Yeah? Right, let me explain that again. A compound is a molecule. So that means all compounds are molecules, because in all compounds you have 2 or more different types of atoms chemically bonded together. But not all molecules are compounds. What do we mean by that? Remember diatomic elements. They can exist as molecules. They can exist in 2s. Hydrogen is H2. That means 2 hydrogens bonded together. Are these different types of atoms? No, it's only one type of atom. So it's a molecule, but it's an element. What type of molecule? It's an element. So basically what I can tell you is that, let me see if I don't have space now. I can tell you that molecules, to make it easy for you, are divided in 2. You can have elements and you can have molecules that are compounds. So all those that are compounds basically have different atoms. Elements are molecules with the same type of atoms. So those are your molecule. Elements are molecules with the same type of atoms. I hope that makes sense. Good. So, like I explained, what is the difference between a molecule and a compound? A compound is a molecule that contains at least two or more different types of elements. All compounds are molecules, but not all molecules are compounds, because we know molecules that are diatomic, made up of one type of atom. Good. So, still again, another example: molecular hydrogen, molecular oxygen, nitrogen. Those are some of the few. Those are elements. But once we say H2O, it's made up of two or more different types of atoms. That is a compound. It's no longer an element. So all these here that you see are molecules. But the ones above that are made up of only one type of atom, they are called elements. And the molecules in the bottom over here that are made up of two or more different types of atoms are called compounds. Good. Let's skip this. Good. So when a compound is broken down into its smallest piece, it is called a molecule. You should be able to write the formula for the following. See, water is H2O. This is just a revision of what we just did. Water is H2O. Is it a molecule? Yes. What type of molecule is this? It's a compound. Why do we say it's a compound? It's made up of two different types of atoms, that is hydrogen and oxygen. Oxygen as a molecule, it exists as O2. It's basically two oxygens bonded together. Is it a compound or is it an element? It's an element. Why is it an element? It's made up of one type of atom, which is the oxygen atom. Carbon dioxide is made up of carbon and two oxygen molecules, two types of atoms basically. What are those atoms? Two different types of atoms, carbon and oxygen. And then, is it an element or a compound? It's got to be a compound. Why is it a compound? Because it's made up of two types of elements. Are we together? Great. Now let's end it here. I'll make a video explaining chemical reactions, and then we'll be good to go for this term's work.